Okay, so um, this lecture will cover the methods part of a within subjects design. So this is part 2 of chapter 10. Okay, so last week we talked about independent designs or between subjects designs. We talked about simple experiments, what are independent and dependent control variables, why experiments are even necessary for supporting these causal claims, and then talked about independent groups design or between subjects design, and then independent samples t-tests. This week we're going to talk about within groups design and order effects, pros and cons for the differences between subjects and within subjects, so like why and when do you choose them, and we'll interrogate all causal claims regardless of the design with our 4 validities that we covered in chapter 3. Now this week we're also covering dependent samples t-test, but that's a separate lecture than this. Okay. So first thing, within groups design and order effects. So when we talk about within groups design, we're going to talk about either concurrent measures or repeated measures design. And we'll talk a little bit about the advantages and issues with a within groups design. And then we'll talk about whether a pre-test, post-test design is between subjects, and we'll talk about why it's not. Because a pre-test, post-test design is actually a between groups design that you talked about last week, not a within groups design. All right, so a concurrent measures design is essentially where you present both levels of the independent variable at the same time. So a within subjects design in general is where all your participants are exposed to both levels of your independent variable, or all levels of your independent variable, whether you have 2, 3, 6, whatever. In this case, we only have 2. But a within subjects design is where you expose all of your participants, every single one of them, to every level of your independent variable. A concurrent measures design is where you expose your participants to both levels at the same time. So let's say you have one group of participants and you wanted to see their looking preference. This is very common in preferential research or decision-making research, to see where people automatically look first. And so what you do is, let's say you want to see if they prefer to look at a male face or a female face. You present both faces at the same time, and then you see where they look. That research with children anyway looks a little bit like this, where, let me bring out my little laser pointer. The participant is sitting in front of the screen, and they get exposed to both levels of your independent variable. In this case, the bunny rabbit that's creepily sitting in front of a chicken costume or baby chick costume is doing something on their own, and in this case, they're doing something together. They're synchronized. And what you essentially do is you see where they look. Now here, you can't really see very well, but there's an eye tracker right there that's tracking the vision of this child to see which side of the screen they're looking on. Okay, so in the looking paradigm, you would want to use a concurrent measures design where you're presenting both options and seeing a preference, right? The more common type of within subjects design is what we call a repeated measures design. So repeated measures design is where you present the level 1 of your independent variable, then you measure your dependent variable, then you expose them to another level of your independent variable, and then you do the same dependent variable again. So let me give you an example. So you have one group, and everybody in that group, individually, they don't have to all do it together. So you only have one group though, and everybody in that group, let's say you wanted to see whether how much someone likes chocolate differs depending on whether they were alone or with somebody in the room. And so you give chocolate to your participants, when they're sitting in a room with somebody else, and then you have them rate their chocolate, how much they like it. Then you give them another piece of chocolate, but when they're alone, and then they have them rate their chocolate again. So every participant in your group is exposed to level 1 of your independent variable, tasting chocolate with somebody, and level 2 of your independent variable, which is tasting chocolate alone. And they have the same dependent variable, right? So your independent variable is whether they're alone or not. And so this is level 1, not alone, level 2, alone, and your dependent variable is just one thing, rating the chocolate. And you might see a difference, right? So having chocolate with somebody, having a shared experience might result in higher chocolate rating than having an unshared experience. Okay, so repeated measures design is where everybody in your group, everybody is exposed to all levels of your independent variable. In this case, we have 2 levels of our independent variable, and therefore every participant got exposed to 2 levels. Now, why would anyone do this? What is an advantage of a within groups design? Well, if you remember last week when we talked about between subjects design, we talked about how you might need lots of control variables. Why? Because people are different, right? So think about it in terms of liking chocolate. I personally love chocolate, much as I like pasta, if you remember my obsession with pasta last week, right? I just love food in general. But I have a friend, I don't know why I'm friends with him, because he doesn't like chocolate. He thinks it's disgusting because he's a crazy person. But there is variation between people. And so when you have a within subjects design where you only have one group and everybody in your group is exposed to every level of your independent variable, they serve as their own control. I don't have to gauge at first who likes chocolate and who doesn't, because they serve as their own control. When they take the you're not looking for overall scores, you're looking for difference in scores. And when we do the dependent samples t-test, you'll see like what you're doing is subtracting the score from time 1 to time 2, or from level 1 to level 2, or from level 2 to level 1. You're getting a different score, and that's what you're examining, because each participant serves as their own control group. These designs also give researchers more power to notice differences between conditions because it eliminates unsystematic variability, or minimizes unsystematic variability. Again, the differences between groups that naturally occurs. And so that gives us more statistical power, aka larger effect sizes, aka larger Cohen's d, to refer back to what we learned last week about independent samples t-test. And then third, and usually this isn't necessarily true, and I'll explain why in a minute, but within groups design typically require fewer participants than other designs. So if you have a between subjects design, also called independent groups design, and let's say you have condition 1 and condition 2, you have 20 people per condition, right? So if you have 2 conditions, you need 40 participants. In a within groups design, let's say you want to test 20 people per condition. Well, you only still need 20 people, because condition 1, you have 20 people, and condition 2, you have the same 20 people. And so you only need to test 20 people, whereas in an independent groups design, you have to test 40 people. I'll talk about in a second when we talk about counterbalancing, how that's actually not necessarily true, because you want to control for order effects within groups design. So we'll talk about that in a second. So why wouldn't everybody do within groups design? Well, it doesn't make sense for every type of design. The most common problem with a within groups design is called an order effect. An order effect is an internal validity issue, and it essentially states that being exposed to one level of your independent variable might impact how you respond in the second level of your independent variable. Meaning, being exposed to one condition affects how you respond to the second or next condition. The 2 types of order effects that we're going to talk about are practice effects and carryover effects. Practice effects is where participants either get better at a task or worse at a task due to fatigue or practice. So let's give you an example. So let's say I wanted to see whether the effect of practicing vocabulary words on the effect of retention on a test. Okay, so I either make my two independent variable levels are you practice for 45 minutes or you practice for 2 hours. And I want to see which one has an effect on actual retention. So when I tell you, hey, you should study vocab, should you study for 45 minutes or should you study for 2 hours, right? That's a valid research question. So if I have a within subjects design, a within groups design, and I make my participants study for 45 minutes, and then I give them a vocab test, and then I make them study for 2 hours, and I make them take a vocab test. Well, if you just studied for 45 minutes, and then took a vocab test, studying for 2 hours, you are what we call fatigued. You're like, I don't care, right? You don't want to study for 2 hours after studying for 45 minutes. You are tired. You're mentally exhausted. This is a version of a practice effect. Alternatively, you could get better at something over time. So let's say you want to study, let you study for 45 minutes, give you a vocab test, and then by the time you go to study for 2 hours, you're quite familiar with these vocab words. And so you're like, I got this. I'm really efficient. And so you're better at your DV. You're better at the vocab test because you've gotten really good at studying. Or it could be a carryover effect. Carryover effect is another way of saying that your first level contaminated or allowed you to carry over information or behavior from one condition to the next. Sticking with our vocab example, so if you study for 45 minutes and you got the vocab quiz, by the time you go to study for the 2 hours, you already studied these words for 45 minutes. And so if you found that after 2 hours, your score on the vocab test is higher, it could just be because you already studied these freaking words for 45 minutes. And so that knowledge isn't just blanked out after you take the test, right? It carries over into your next condition. So that's an example of a carryover effect. So if this is a really big issue within groups design, this order effect that the order of your conditions has an effect on your behavior, what do we do? So the best way to avoid order effects is by counterbalancing. So we're going to talk about two types of counterbalancing: full counterbalancing and partial counterbalancing. Specifically, we're only going to talk about a Latin square. We're not going to talk about, there's lots of other types of counterbalancing. We're not going to talk about those. We're just going to talk about full counterbalancing and the partial counterbalancing of a Latin square. So what the heck is counterbalancing? So counterbalancing is taking your one group and splitting it into two groups. But all your participants still get exposure to every level of your independent variable. So for example, let's say I have group one, and let's stick to the example of the chocolate. So they're exposed to level one of their independent variable, given this should have a test, your DV, then exposed to level 2 of your independent variable, and then given your DV again. And then a different group, split up by group, first gets the second level, so level 2 of your independent variable, then level 1, and then the DV. And so what you're doing is you're splitting the order. And so what was once the independent variable 2 was exposed second, here, independent variable 2 is exposed first. So to map it out, so let's say you randomly assign, you still use random assignment, you randomly assign participants to either be exposed to independent variable level A first, then the DV, then exposure to independent variable level B, or a different group of participants, right? So you still have two groups, but it's still considered repeated measures. It's within groups because they're being exposed to every level of your independent variable. So the second group is exposed to level B first, then DV, then level A, the first level. So what does that look like with our example of chocolate? So before, when I first exposed this to you, we only had the top where you taste chocolate. No, we only had the bottom, sorry, where you taste chocolate with the Confederate, then you rate the chocolate, then you taste chocolate alone, and then you rate the chocolate. If you're counterbalancing, you would have two groups. You randomly assign participants to one of these two groups. They taste the chocolate alone in this one, then rate the chocolate, taste the chocolate with the Confederate, and rate the chocolate. So alone, not alone. But alone is exposed to this group of participants first. And then this group actually tastes the chocolate with somebody first, rate the chocolate, and then taste the chocolate alone. And so even though you have two groups, this is still called a within subjects design, because the idea is that it's all about whether they're exposed to every level of your independent variable. That is what makes a within subjects design. So this is called full counterbalancing, where all possible condition orders are presented. And it's really easy when you only have two levels of your independent variable. But if you have three, it becomes complicated, right? So you go from having two groups to six groups. It's exponential, where first you expose to level 1, level 2, then level 3. Then level 1, level 3, level 2. Then another group gets level 2, level 1, level 3. Another group gets level 2, level 3, level 1, right? You can see how this becomes kind of problematic. If you have 4 levels of your independent variable, it looks like this. You have 24 groups if you're doing full counterbalancing. So this gets out of hand, right? And so whenever you have more than 3 levels of an independent variable, we actually say it's better to do partial counterbalancing, because having 24 groups is ridiculous. Trust me, I tried to do it for my master's thesis, and my advisor was like, "Are you sure you want to do that?" I'm like, "Yes, I want to do full counterbalancing because I'm stupid." And I did it, and it was awful. Don't do it. So partial counterbalancing, in this example of a Latin square, is where only some of the possible orders are used. In a Latin square, every possible combination occurs at least one time. So what that means is where here you have the order of testing conditions. So if you have 6 conditions, so first, second, third, fourth, fifth, and sixth. So one participant gets exposed to order 1, 2, then 6, 3, 5, 4. And so you'll see here in the order of testing conditions, at least all these participants, so the order of testing condition 1 is exposed to at least one participant. The order of conditioning the independent variable 2, level 2, is appeared first at least once. Then independent variable level 3 is exposed first at least once. Independent variable level 4 is exposed first at least once. And this goes for every order. So independent variable level 1 is exposed second at least once. Independent variable level 2 is exposed second at least once across the participants. And so what this allows you to do is control for the order of things, essentially by having at least some of the orders represented, but you're not doing this where you have 24 groups. So here you would have, instead of participants, maybe you can put this into groups, you'd have 6 groups or 6 participants rather than 24 if you do a Latin square. Okay, so I wanted to take a step back. If you remember last week, we talked about a pre-test, post-test design. And very, 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 very commonly, students tell me, well, isn't that a repeated measures? Because you're repeating the measures. You're measuring once, exposure to independent variable, and you're measuring twice, repeating the measures. And yes, this is super confusing, but in this case, a pretest post-test design is actually a between subjects design. If your group is only exposed to one level of the independent variable, it's actually not about how many times a DV is presented or how many times a DV is measured per participant. What is the big difference between a pretest post-test design and a repeated measures design, which is technically also a pretest post-test? So look, we could call this a repeated measures pretest post-test, and we can call this a between subjects pretest post-test. But the only difference is whether they're exposed to every level of the independent variable. In a between subjects design over here, you're randomly assigned participants to either get exposure to one level of the independent variable or the other. Whereas in a repeated measures design, you randomly assign, let's say, assuming you're counterbalancing, you randomly assign participants to either get exposure to level 1, then level 2, or exposure to level 2, then level 1, right? The fact that you're measuring the DV twice for both of them is irrelevant. What matters is exposure to every level of the independent variable. And so if you have exposure to every level of the independent variable, it's repeated measures or within subjects. If you're only being exposed to one level of the independent variable, it's a between subjects pretest post-test. Okay, now let's briefly talk about the pros and cons for between subjects and within subjects. We're talking about both types of designs now. So again, which design is better? The research question determines which design is better to answer your question. So in some situations, it's actually really problematic to use a pretest post-test or within subjects. So for example, the pasta study. If you had the pasta study, you don't want a pretest post-test and you don't want a within subjects design. You don't want either. You want a post-test only design, right? So imagine if for a pretest post-test, if I made you eat pasta, then given you a medium-sized bowl, then made you eat pasta again, by the time you eat the second bowl of pasta, you're like, I'm gonna die, right? You're in a food coma. You also don't want to use a within subjects design because, again, you're making them eat pasta twice in a medium bowl and a large bowl. That's not going to work. Even if you counterbalance, that wouldn't work, right? In this case, a post-test only design works where you give them either a medium bowl or a large bowl and you see how much pasta they take. That's the more effective design for this research question. But in other situations, in other research questions, these designs make more sense. So the chocolate study, for example, it makes more sense to use a within subjects design because you want to control for how much someone likes chocolate. Or you can even use a pretest post-test design where you have them rate how much they like chocolate, then give them the chocolate either alone or with somebody and then have them rate their chocolate again. That could work as well, right? It's not to say that a pretest post-test or a within subjects is better. Sometimes a simple post-test only design can be very powerful as long as you use control variables and have random assignment. So what are the pros and cons for independent groups and within subjects designs? So independent groups requires more people, which is kind of a downside, and you have to have more control variables, but there's no contamination or carryover effects across your levels of the independent variable. In a within groups design, typically requires fewer people, but again, that's not necessarily true because if you have to counterbalance, you're actually adding another group anyway. But individuals serve as their own control, which gives you more power to detect actual differences. But it has potential order effects, right? And the chance of experimental demand, which I'll talk about right now. So when you do a within subjects design, one potential problem is that experiencing every level of your independent variable might change the way participants act. These are called demand characteristics or experimental demand. And it essentially happens when participants pick up on cues that lead them to guess what the purpose of the study is. And so they, for example, in the rating of the chocolate study, they might guess like, oh, well, you're giving me chocolate and then having me rate it. And then you're giving me chocolate again, you're having me rate it. Maybe you want me to like this chocolate. And so they might change their behavior simply because they either accurately or inaccurately, they pick up on cues that let them guess, correctly or not, what they think the purpose of the study is. And so they adjust their behavior. So another example of a demand characteristic is, imagine if I'm studying, if my experiment is testing the effect of studying on grades. Well, if you're in a study about studying, what do? You study more, right? You focus on studying because it is an experiment about studying. So sometimes we lie, essentially. We use deception as a way of hiding what the purpose of the study is so that we eliminate or minimize demand characteristics. But this is really more a problem in a within groups design, because once you expose participants to different levels of the independent variable, then they have a greater chance of detecting or guessing what the purpose of the study is, and then they adjust their behavior. Okay, finally, we're going to interrogate causal claims using the 4 validities that we talked about in chapter 3. So, interrogating the causal claims with the 4 validities, we're going to talk about construct validity, external validity, statistical validity, and internal validity. So construct validity is essentially how well were the variables measured and manipulated. You have to worry about this for both the dependent and the independent variable. For the dependent variable, how well was it constructed? How well was it measured? So for example, if in the chocolate study where they had to rate how much they like chocolate, I can give you a simple 1 to 10 scale. But in something more complicated like empathy, right? How do you measure empathy? How empathic do you feel? Most people don't really understand what that is, right? So your dependent variable has to be a reliable, valid measure of empathy, for example, or intelligence. Should I just say, how intelligent are you on a scale of 1 to 10? You're like, I'm a 10, obviously, right? No, you want an IQ test, but an IQ test takes 4 hours. So you might want a shortened version, maybe a different measure that taps into intelligence, right? So when you're talking about construct validity, you want to make sure that your dependent variable is something that's operationalized well. You also have to worry about the construct validity of your independent variable. How well were your independent variables manipulated? So you can do this one of 2 ways. You can either use something that someone else has already used and has already been validated. So for example, the study about note-taking that we talked about last week, note-taking either by hand or by computer. This is a really simple independent variable manipulation. They either got a notebook with pen or they got a laptop with no notebook and pen, right? And so the manipulation was really simple. But other independent variables are less easy to differentiate, right? You want to make sure that something, it was different enough. So for example, let's say I want to see if money makes you happy, right? And I give you either $100 or $10. Well, that might be enough, right? That difference between your 2 levels of the independent variable might be a good manipulation. Or if I give you $1 and $5, the amounts are still different, but they might not be different enough to actually impact your dependent variable, right? And so the best way to do to see whether this is enough is a manipulation check. If you're not already using a validated manipulation, you can do a manipulation check where you do a study where you see whether there's a difference in your dependent variable depending on your independent variable manipulation. You could also do a pilot study. So if you don't want to run a full study and you want to just see if something is working, we do a pilot study. Pilot study is like a mini study that you do before you do the big study. And it's a way to make sure that your independent variable is actually impacting your dependent variable. External validity essentially asks to whom and to what scenarios can this claim generalize to. So if you find something, you want to make sure that your effect is generalizable to other people, not just your sample, but to the population, and to other situations. So when we're talking about external validity, about generalizing to other people, we're really talking about sampling issues. So how well were the participants, what kind of sampling was used? Where did they find them, right? Is the sample representative of the population that you're trying to make a claim about? So if you're trying to make a claim about being with people makes you like chocolate more, well, is that generalizable to all populations or just to the college students that you tested, right? So external validity is really a problem in the field sometimes because we tend to collect data from college-age students, right? Or at least a college population. And this might be a problem, right? Because students that go to college tend to be of higher intelligence, middle class or above, have access to resources that are different than those that may not go to college. So you want to make sure that your effect is generalizable to other people and also to other situations. And so if I make you rate chocolate, whether you're with somebody or alone, is that true for all food or just chocolate, right? So does it matter that it's only that chocolate is the thing that was tasted, or is sharing an experience that is not associated with food, or maybe like a meal, not necessarily a snack like a chocolate, but a meal, is that also better with people versus being alone, right? So different experimental conditions. Now, as you read studies, if you're ever actually examining using these validities, you might see that external validity tends to be a little poor in the field of psychology. Again, we tend to test students in college, and we have a problem called the weird problem, where more than 75% of the studies that we publish collect data from a weird population or a weird sample, westernized, educated, industrialized, republic, and democratic, right? And so we are different than the rest of the world, right? The majority of the world is not that rich and democratic. Sorry, not Republican democratic. Rich and democratic. Rich being doesn't mean that you have to have lots of money. Rich being you have access to basic necessities and resources such as running water, shelter, and basic foods, right? As a country, we are very rich, even though there are individual differences. And so what happens if external validity is poor? Does that mean that my study is meaningless? Not really. In experiments, what we're really focusing on is, all the other validities are important, but internal validity, experimental control, making sure that the only thing that differs is in your independent variables or what you're manipulating is paramount, right? So in order to achieve experimental control, in order to say that the difference in your DV is actually caused by your independent variable, we sometimes select people that are a convenient sample, and we sometimes conduct studies in artificial scenarios, artificial lab environments that don't necessarily represent the real world, but make sure that we can say for sure that this independent variable is the thing that is impacting this dependent variable. Now, that's not to say that we shouldn't try to make studies more realistic, and we shouldn't try to sample more people that are non-weird. but it means that external validity is not the more important validity. We tend to favor and prefer high internal validity, even if it's at a somewhat of a cost to external validity. The third validity is statistical validity, and this is asking how well does the data support the causal claim, right? Essentially, is the difference statistically significant? And we're going to talk about this when we talk about in the next part of this week's lecture on how to run a dependent sample t-test, and we talked about it last week when we talked about independent sample t-test, right? Is your t value more extreme than your critical t? Right? Is there a significant difference? And even if there is the effect meaningful? Is there a large effect? We use Cohen's d to tell us about the strength or the size of this effect. And so we tend to have these guidelines. So a Cohen's d of 0.2 is small or weak. Cohen's d of 0.5 is medium or moderate. A Cohen's d of 0.8 or higher is large or a strong effect. And Cohen's d is essentially a function of variance, as you've also learned in an independent sample t-test last week. And again, you'll learn about variance being important for this week. But let me just to demonstrate, we have the same effect here where in the orange side, we have a mean for group 1 of 9 and a mean of group 2 for 11. These are significantly different. And we have a Cohen's d of 0.56. This Cohen's d is higher than the Cohen's d here, even though group 1 still has a mean of 9 and group 2 still has a mean of 11, because the scores here are less variable. They are closer together. They're more similar, which means that group 1 is more similar to itself and group 2 is more similar to itself and less similar. There's less overlap between these two groups. So they have lower variance between groups, means a greater effect size. The effect is greater. However, here again in the blue side, even though they have the same means, 9 and 11 for the two groups, the scores are more spread out. The variance is greater. And so because of that, they have a lower effect size. The effect is small, which means that there's lots of overlap between these two groups. Group 1 is not so similar to itself, and group 2 is not so similar to itself. They're more similar to each other. So even though they're significantly different from one another, it's a minimal difference. The effect is small. Okay, so that's what effect size means. And then finally, the coup de grace, the more important one, and the one that really matters for a causal claim, is internal validity, which essentially asks, are there alternative explanations for the outcome, for the effect that you have? So the three fundamental questions that you should ask when we're talking about internal validity, as long as it meets the three criterias, is were there any design confounds? If you use an independent group's design, did they have any control variables? Did they control for selection effects using random assignment? If you're using a within groups design, did researchers control for order effects by counterbalancing? All right. And that is all. If you have any questions, please let us know.